Yeah, hi Sri. Good evening.
Hello.
Yeah, hi.
Hmm.
Today only my Pongal meal has been done.
Okay. Yeah. Is that okay?
Yeah, yes, yes.
Okay. Okay. Okay.
From tomorrow also, tomorrow onwards I need to start all my works.
Yeah, yeah. Just 1 minute. Just 1 minute.
Okay.
Okay. We actually discussed about yesterday Snowflake views. Like what are the different views? I shared the recording also, and
Okay.
you can go through that once because views basically are similar to other database views here also. The only thing is like we have extra secure use and the semantic use. But in Snowflake, we have normal views, metadata views, secure views, and semantic views. And in Snowflake, metadata views are having some limitations where you cannot go and create this meta views more than on one table by joining. So these kind of limitations uh, is giving some challenge for the developers to use them, and that is why we got dynamic tables. The solution for the limitations of material use, we Snowflake came up with another feature called dynamic tables, and where you can create a dynamic table by joining the more than one table also. That I'll discuss about dynamic tables later. But today, just give me a minute. I want to discuss about some part. Did we discuss about time travel and fail safe?
Oh, yes, we
Okay,
discussed.
we did right. I think we did. Just check one thing. Okay, I hope we have not discussed about the zero copy cloning, correct? No, did we discuss about zero copy cloning? No, right?
No, no.
Okay, let us discuss about it. Okay, so when I say zero copy cloning, let me share my screen. Sharing my screen, is not able to see. Yes, that's not able to see my screen. Can you see my screen?
Yes.
Okay, when I talk about zero copy cloning, and in Snowflake terminology, we call as cloning also. So cloning means what? Exact replica. Correct, no? So whatever you see here, this one and this one both are almost same. So just take a copy. But how Snowflake is helping in implementing this cloning, how it is helping the customers, why people are using zero copy cloning, and how zero copy cloning can help us in reducing the cost, storage cost, and how it can help us to create different other backup environments and backup databases. We will see that. So when I talk about zero copy cloning, Snowflake is offering this particular feature to the customers who wants to create a exact replica of their databases or schemas or tables in seconds. Even my database is in petabytes of size. Within a fraction of seconds, I can create a copy. When you go to normal traditional databases, you can imagine how much time it will take to copy a database with another copy. Go to Oracle, it will take so much amount of time. SQL Server also. And what is the second challenge? The first challenge is how you are going to create the backup. And what is the second one? The storage, right? Correct or not? The storage also one of the burden I need to buy. In normal traditional databases, you need to have an extra burden of your storage cost. If your source database is 1 terabyte, to create another copy, you need to have 1 more terabyte extra, and where you need to buy. That is one of the biggest challenge. But in Snowflake, we can create or maintain multiple copies of your data with no additional cost. So we call this as zero copy. For example, I have a table with 1 terabyte. If I create a cloned table with the same table, the cloned table storage will be zero. Only the source table will be charged the storage cost. 1 terabyte cost will be only applicable for the source table, and the cloned table storage cost will be zero. And if you remember, while discussing about Snowflake pricing, we discussed about the Snowflake storage cost also per terabyte. Is correct? You know? Yes or no? So when you are Snowflake is going to charge the customer, they will charge not only compute cost, they will charge by storage cost and data transfer cost also, right?
Yes.
So the storage cost what Snowflake is going to apply to the customer is not applicable for cloned data. The cloned table or a database or a schema, whatever it is, you will not going to be charged. And the cloned object, it can be database or a schema or a table, can be modified and independent of the source table or database or schema which you used. For example, if I change any data in the cloned table, the source table will not be impacted. And after you cloned from a source table, if you change anything in the source table also will not going to reflect the cloned table. Both are independent. And when people use, so there are two popular use cases where cloning will be used. Like the first and foremost thing is the production database replica I want to create, like development and test environment. Then I will, instead of creating a copy, physical copy, I will clone production database with the dev and the test databases. And anytime I want to create any backup databases also, cloning will help. Correct, no? So I do not need a here I can create my backup database without any cost, right? So people can definitely will go can leverage, right? For example, I have a like a challenge in maintaining the data. I will create a copy of it before I change it. My entire production database, I want to keep some part of data to be stable. I don't want to change it. Then I create a copy of my entire production database and I clone it. My cloned database I'll keep aside, and only the actual database I'll try to keep. So in that way, I can have a backup also. So many people use cloning for backing up the data and creating the testing and developed environments. So this is the original database object and version table, and we are cloning it. So instant metadata only will be copied. Actual data will not be as it is copied, because the actual data will be the same micro partitions. Both will share the same. So whatever everybody remember about micro partitions, right? A micro partition, every table in Snowflake is divided into a group of micro partitions, maybe 1,000, for example. Each micro partition represents one file. If I have 1,000 rows, all the rows will be divided into a group of micro partitions, and each micro partition here, whatever you see this box, will have some set of rows. And when you clone this particular table, this cloned table also will point to the same micro partition. So in that way, we are saving that storage cost or not, my question. Yes or no? Since both are sharing the same location and we are not physically copying, you are not physically storing any data, so you are saving the storage cost, right?
Yes.
Assume that you have 1 terabyte, then you can maybe like 1 GB, it may not be that much difference you can see. If you go and see 2 terabytes production database, and I want to create a development and test, I need additional 4 terabytes. But here we are saving that 4 terabytes cost, right? Everyone? Yes or no? Are you able to understand?
Okay, sir.
So we are saving the storage cost here. That is what you have to keep in mind. People when ask you how zero copy cloning can help us here is, it will help you to save the storage cost. That is what you have to remember and understand. And second thing is, zero copy cloning is basically will help in no data duplication. So we are not duplicating the data here, because we're pointing to the same micro partition. And if you change anything in the source table, that will not be reflected in the cloned table. And if you change anything in the cloned table also, will not be reflected in the source table. So both will be independent of each other. And this will be very suitable for testing and debugging of your environment and super fast copy. Correct, no? So within fraction of milliseconds, I can copy my entire production database or table or schema to my cloned database or schema table. Because the clones will share the same micro partitions. If any changes will happen, then only the new micro partitions will be created. For example, if I change anything after I cloned my source table with another table, if I do any changes in source table, Snowflake will only try to create another micro partition with the changed data. In that way, it will differentiate which are the partitions that are pointed to by cloned table, and any partition that is new will be independent of cloned data. Even the same thing will happen for the cloned table also. If you change anything in cloned table also, Snowflake will create a separate micro partition for the changed data, so that it will not disturb the actual cloned partitions. So this is an example. If you see here, I have micro partition 1 up to 8 micro partitions of this employee table, employee data. And if you clone a table, you see employee clone is a table, and it is, see, if it is pointing to, so for example, this is the timestamp start, and it is, there is any timestamp. So if you observe here, the cloned micro partitions, it is using like micro partition 1 to micro partition 5. These are same. The same micro partition is using. Whenever there is a change, a new micro partition got created, MP6 here. This is the changed data of this table. This is red color. Similar to that, these two are the micro partitions which got changed in this particular employee table. So this MP7, MP8 are for employee table, MP6 is for this clone table, but 1 to 5 are in both tables. Which means that when you cloned this table, the first 5 partitions only were available. After I changed this table, I got this new one. After I change this, I got these two options. So which means that when you delete any records, for example, or any particular micro partition, that is not going to impact either one. So that is what you have to understand. So the main common use cases for cloning is, to summarize, to create development and testing environment and create backup and recovery, recovery and data science and analytics. Whenever they need any additional environments, we will create by creating a backup environments, and any kind of demos I want to go and conduct, I can use cloning separately, and I can use that particular clone databases or clone environments for giving the demo and all. Instead of touching the entire actual mm, production database, I will create a backup by cloning, and I use the cloned one in the demo so that I will not disturb the existing production database. So coming to how to create a cloned object is like I need to use create. For example, it can be table or a stage. I can clone all these objects what you see. So I can create a table, clone a table, create table, maybe customer, and my table name I want to get customer clone, clone customer table. So that is how you can create a clone table. So create table like customer clone customer means a customer clone table will be created by using the customer table data. So I can even clone the entire schema. When you clone entire schema, all the tables of that particular objects of the schema will be cloned. If I clone the entire database, all the schemas of the database will be cloned. That is how you need to understand. So databases, schemas, tables, and I can also clone, views, file format, sequences, streams, tasks, types, everything I can clone. So people may ask you, what type of objects I can clone? You need to tell all this. So whatever available here can be cloned using the zero copy cloning. And coming to how to create, as I mentioned, this is a database I'm creating. Can you see that? Create database clone DB, clone original DB. And I'm creating a sales data table and inserting some data. So after I cloned this one, this particular table will be present in the cloned DB also, right? Correct or not? Are you getting what I'm trying to say? All of you. This table sales data which you created in the original DB will be available in the cloned DB because we are cloning the entire database. If I have multiple tables, all tables will be available in this cloned DB. And it is not going to copy the actual data, it is only going to copy the metadata because metadata will point to same micro partitions by both clone table and the actual table. And this is basically an XML example which I was talking about. So we are simply cloning production DB table, and we are just creating a table and we are just trying to create a backup of that. So anytime if you deleted something, I can restore from the actual cloned table also. Correct? No? Okay, this particular cloned table I can use and I can restore, right? Correct or not? All of you. We accidentally deleted something from the main table, I can use cloned table, right? Are you getting what I'm trying to say? Okay, great. So that's how you need to implement zero copy cloning. So when you implement zero copy cloning, you, according to your project demand, you will use in different ways. So for example, supply chain example here, where you will try to create where I want to simulate a logistics. So I want to go and update some data. So I don't want to touch the actual production database. I will create a separate database for this particular simulation, and the simulation database will be used for As a database, we'll use that for our logistic simulation. And anything I want to implement using inventory optimization also, I can use a new database can be cloned for that and we can use that. So that's how you need to understand the use cases. So all whatever you see, these are some of the use cases which I like added here. You can just go through and uh, understand. And zero copy cloning to implement, I need to use the clone keyword. Create database name, clone database, or create table name, clone table name. Create schema name, clone schema name. So you need to follow the same for every object. Normal traditional cloning, you see, you are creating a duplicate copy and the cost is involved. But here, since we are sharing, no cost is involved in the zero copy cloning. That point you need to keep in mind. Very, very important. And how can I implement that? So what we do, we'll try to. Here we'll try to create one worksheet. So we will try to use the same English data database known as schema. So let us try to, or we can create a new database also. Let us try to create this demo DB. I'm just creating. I'm also creating a demo schema. So, I'm also creating one more schema here. So two schemas, and I'm trying to create some tables here. So we are just pointing to the demo DB, but I will change the schema to the first schema, demo schema. So whatever the table I'm going to create will be created under this demo schema by initially. So what I'll do, I'll just try to create this table, and the table has been created where you can see in the demo schema. You will see the customer table which we created, and we'll try to insert some data as well. And before that, let us create the others table also. And now we'll add insert some data customers. And if we go back and run this, so this is the data. Now let us try to capture the timestamp. Let's copy this. And what I will do, I will try to create a view by selecting the New York customers, only city New York customers, and I'm just creating a view for that where we will go and try to select some data. These are all the customers under New York, these two customers, and we can try to create an internal stage and load the data also. And as soon as you created this particular data loading, so my table is already there. So what I'll do, I will try to create a cloned schema. Can you see that? I'm just creating a schema from the demo DB. I'm just creating a cloned schema with the actual schema. So which means that both will have the same tables, correct? No? So for example, you go here, there is one more schema which will have the same tables. Can you see that? It contains even the view also. When you clone a schema, it is cloning everything. The cloned schema contains whatever the tables, two tables, and is viewed automatically. But this particular cloned schema will not consume any space. Only the actual tables and view of the main schema only will consume the physical storage. So I can go back here and I can check. For example, if I insert any data into cloned table, for example, I'm just trying to create a table with name in the demo schema. I'll move to demo schema and I create a cloned table here. So if I go back and run, you will see a cloned table now. Both are having same data, but customers is having 4 rows. Customer clone is also will have the same number of columns, but both will share the same macro partition because both are pointing to the same data. Now I will insert some data into customers. So when I insert the data, like 678 I'm inserting, the 678 should not present in cloned table, correct? No? Do you agree? All of you? So when I see
Yes.
cloned table should be independent, right? Both should be independent. Okay. As of now, 5 is present here, but in customers, I will see 678 also. But the 678 is not present in customer clone, right? Because that is independent. So anything you change, either in the cloned table or main table, those changes will not be reflected in each table. That is what you have to remember. And apart from that, when I insert any data into cloned table also, for example, I'm just inserting one row into cloned table, like 10 is the ID. So when I go back and see in the customers table, 10 will not be present. So 10 is not present here, but 10 will be present in the clone table because we inserted into clone table separately. So now you should understand the clone table and the source table are independent of each other. Is it correct? Yes or no? And we can also use a time travel and cloning together here. I'm creating a clone table, and after I inserted the data, for example, I inserted the data whatever here, here and here. I don't want these tables. I want the old tables without 678 and without 10. Then I will use this method. Create table name clone customers before the timestamp. So before the time, whatever we collected here, before this time, my data is without 678, right? The customers table, yes or no? After we selected this date time, after that only we inserted, right? This data. And if I say before, I should not see 678. Is it correct or not? My question. All of you. If I give here the time which I collected before running the insert statement, this insert statement. Before running this insert statement, this time was collected, whatever is pasted here. So when I go back and run this, I should see the old data. So when I run this, you will see the old data only. When I go back and select the data from this customer cloned uh, insert table, you will not see the 678 records because we just cloned with the old data. Before the 678 was loaded, see 678 is not even present because whatever I cloned here, this data is before this time, and this time we collected before we inserted this particular 3 rows. So 678 I insert into customers. Before inserting only, I collected this time. So that time travel helping me to clone with the data that is available for in the first time insertion. So now, how can I go and select? How can I conclude that the data is cloned and not consuming any storage? So for that, we need to use some metadata views. Let us try to see that. Let us try to see what are they cloned. Is it contains in storage or not? So we can use the metadata views like a table storage matrix, and in that I can mention. So my table name is customer. I use that here, and my database name is demo underscore db. So catalog means demo db. So when I run this, so I will see the cloned data as well as we are showing the okay. This graphic customer. So this will show us see all these customers, and you can see the cloned data also. So wherever you see this one and this one, second and fourth rows. Second and fourth rows, we can say active batch 0. Can you see that? Yes or no? Can you see that? Everyone.
Yes.
So which means that it is cloned from. See if you observe here, 7128 and 7174. So this is cloned. This is cloned from this particular customer table. This also cloned from which particular table? 7174 is nothing but this one, right? Correct or not? These two, all this particular one and then this one, both are cloned from 7174 means 7174 is nothing but this one. And the cloned active bytes also 0 because cloning is not going to consume any storage. So Snowflake will not going to charge you anything for the cloned data. Hope that is clear. You guys understood what is zero copy cloning? So to summarize,
Yes.
zero copy cloning is going to create a copy of your database object, and as soon as it will create database object, it is not going to consume any storage. We can use zero copy cloning to create backup environments like development and testing environments, and once after you change the data, you can even restore that. So I can simply clone with the right data. So the cloned object will not consume any storage. That you have to remember. Okay. So I want to discuss about zero copy cloning today and with time travel. That's what we discussed about time travel with zero copy cloning. So whatever you see here, this is time travel with zero copy cloning. So when you are creating a copy of your original data, you can even clone it instead of physically creating the copy. So here we are doing the same. From the time travel feature, we are integrating the zero copy cloning and we are creating a cloned table from the original data so that I will not consume additional storage cost also. Hope that is clear. So zero copy cloning is the feature that will help us to save the storage cost. So storage optimization, we call it as. Hope that is clear. Any questions, Nikhil? Any questions? Ali and Madan. No
No,
questions?
no.
Okay. Then please try to practice this today. So I want you guys to practice zero copy cloning today. I will share the assignments as well to work on this.
Sure.
And please try to work on the hands-on and go through the PPT. And then any specific questions, please ask tomorrow.
Sure.
Very, very important concept because this is going to help you to save your storage cost involved. So when people ask you to create any backup environments, always use this feature. Don't ever create a physical copy because physical copy will consume storage cost. Cloned copy will not consume any storage cost. I hope that is clear. Nikhil, any questions? Nikhil, are you there? Any questions, Nikhil? Nikhil, I can't hear you. I hope you don't have any questions. If you have any questions, you can ask me. Ali, how about you? Ali. So I can't hear even Ali, you too. If you have any other questions, please try to reach out me. And if you want to ask in the next class also, I'm fine. But for today, please try to practice zero copy cloning and which I'm going to share you in the Google Drive and I'll share the link also. Just work on that and come back with your questions tomorrow. That's all for today. Thank you so much.
Thanks, Sri. Thank you.
Thank you.